Hello friends, in today's question, an open glass tube is immersed in mercury in such a way that a length of 8 cm extends above the mercury level. The open end of the tube is then closed and sealed. The tube is raised vertically up by 46 cm. What will be the length of the air column above the mercury in the tube now? Atmospheric pressure is 76 cm of the mercury. So in this case, we are given that there is a tube and it is immersed in the mercury. So let us suppose this is the level of the mercury, and the tube is, in the first case, it is open from the top and it is immersed in mercury. So there is a tube which is open at the top, and it says that the length 8 cm extends above the mercury level. So this is mercury level, and this will be our 8 cm above the level of the mercury. And in the second case, it says that the tube is sealed, and then it is raised additionally by 46 cm. So the total length of the tube outside above the mercury will be our 54. Okay, and now in this case the tube is sealed. So let us suppose this is the sealed tube, and total will be 54. So let us say the length of the air column is our x. Therefore, the amount of mercury inside the tube above the level of the mercury will be 54 minus x. Okay, so this is our air and this is our mercury. So we can say this is our initial condition, and this is our final condition. Okay, and the mercury will be entirely up till this level. And this is our air. So we can say in the initial condition, we have a open glass tube. Open glass tube is immersed in mercury with a length of 8 cm extending above the mercury level. Extending above the mercury level. Now we go for the final condition. And the final condition can be, say, raising the tube. Raising the tube, and which is our final condition. The tube is additionally raised by 46 cm. tube is additionally raised by 46 centimeter. Therefore, total length of the tube above the level of mercury will be equal to 46 plus 8 centimeter. Therefore, total length of the tube above the mercury level will be equal to 8 plus 46, which will be giving us 54 centimeters. And we assume let the height of the air inside the tube is x, the final condition. So we say the height of the air air column above the mercury is equal to x centimeters. Therefore, height of the mercury column inside the tube will be equal to 54 minus x. Therefore, the height of mercury column that rises in the tube when the tube is raised. When the tube is raised will be equal to 54 minus x centimeters. Now we are going to use, you can say, gas law, and which is P1 V1 is equal to P2 V2. You can say according to ideal gas law, which is equal to, basically that is equal to PV is equal to nRT, and RT and N will be all constant, so we can say P1 V1 is equal to P2 V2. Therefore we can write that P1 V1 is equal to P2 V2, where P1 is equal to P naught and V1 will be equal to we can say initial volume, and we can write the V1 will be equal to A is the area of cross section of the tube, and the length is given as 8. So where A is area of cross section of tube, and P2 is our final volume. P2 is our final volume, sorry, P2 is final pressure, and V2 is our final volume. So therefore we can write that our P2 will be equal to P2 is equal to P1 V1 divided by V2, and P1 is equal to P naught, that is our 46. It is given as 76 centimeter of Hg. We will replace it later on. So this becomes P naught V1 upon V2, and we can also write that our V2 will be equal to area of cross section multiplied by the height of the gas inside the, or we can say height of the air inside the tube. And this, we can say, for this gas law is being applied for only the amount of air that is being trapped inside the tube. Okay, so this is only for the amount of the air. For air only. So therefore V2 will be equal to A into X, and V1 is equal to A into 8. So we substitute the values, we get P2 is equal to P naught multiplied by A into 8 divided by A into X. A and A cancels out. So we get here from P2 is equal to P naught 8 divided by X. Let this be equation number 1. Now we are going to find out amount of the pressure, fluid pressure when the tube is being raised. So we can say fluid pressure after raising the tube. Fluid pressure after raising the tube. So as the tube is raised, the pressure inside the tube is modified, you can say changed, for both the air as well as the mercury. We can say from here, when the tube is raised, the pressure inside the tube is modified for both air and mercury. And we already found written that the new pressure P2 is inside the tube. Okay. And we know that the new pressure P2 is inside the tube. Okay, let's draw a simple diagram. So this is our tube which is raised, and we have a mercury, and the pressure inside this air trap is given as P2, and the outside there will be atmospheric pressure which is our P naught, and there will be also the pressure of this liquid column. Okay, so inside the tube there will be two pressure. One pressure because of the air, and another pressure will be the amount of the mercury that is above the level of the mercury. Okay, so let us say that this pressure is our P mercury. Okay. And we know that x is the height of the air trapped, and this height is our 54 minus x. So the new pressure inside the tube, it balances the atmospheric pressure P2 and the pressure due to the mercury. So new pressure P2 inside the tube is balanced by the atmospheric pressure, which is given as P0, and pressure due to mercury column inside the tube. Mercury column inside the tube, and which we said will be given as PHG. Therefore, we can write the equation that P2 will be equal to P0 minus pressure because of the mercury. And the pressure because of the mercury, PHG, there is standard formula that pressure due to a liquid column is given as rho Hg. So this will be rho, density of the mercury, H, height of the mercury, and there will be G. And height of the mercury inside the tube is 54 minus x. So we can write that P2 and so rho Hg is density of mercury, and HHG is height of the mercury inside the tube, and that is given as 54 minus x. So we put here, we get P2 is equal to P0 minus, and this will be equal to rho Hg, HHG, and multiply by G. Okay. And we are going to substitute the value of HHG. So we get P2 is equal to P0 minus rho Hg multiplied by G, and this is 54 minus x. And the P0 in the question itself, it is mentioned that it is 76 centimeter of the mercury. So P0 is equal to 76 centimeter of mercury. It is given to us. So we can write P0 will be equal to 76 multiplied by your density of mercury multiplied by G. So once again, we put all these, let us substitute it here. We get P2 is equal to rho Hg, we can take as common. So this will be rho Hg, in G we get 76 minus, and here we have 54 minus x. So we can solve it further. This will be our 54, and we are left with 22. So this will be equal to rho Hg multiplied by G, and we have here 22 minus x. So let me write it separately. So we get P2 is equal to rho Hg multiplied by G, and we have 22 minus x. Let this be equation number 2. 2. So from equation 1 and 2, from equation 1 and 2 we get, and equation 1 is our this P2 is equal to P naught 8 upon X. So both are pressure P2, so we can equate the right side as well. So we get this as P naught, and P naught is our 76 multiplied by rho Hg multiplied by G divided by X and multiplied by 8 is equal to rho Hg multiplied by G and 22 minus X. So rho Hg and rho Hg cancels out. So in this we are getting it as 76 multiplied by 8 is equal to X into 22 minus X. So which we can write as X square plus, okay, let me move it this side, so this will be minus 22x, and we are going to get this as 608 is equal to 0. So we can factorize it. It will be equal to x plus 38 and x minus 16 is equal to 0. So from here we are going to get either x plus 38 is equal to 0 or x minus 16 is equal to 0. So in the first part we are going to get x is equal to minus of 38, and the second part we are going to get x equal to 16. So obviously it is negative, so we are going to neglect it. Therefore our x is equal to 16 centimeter, which was nothing that was asked for, that is the length of air column of the mercury. Length of air column above the mercury inside the tube. Inside the tube. So the options that are available to us, the option number A is the correct option. So we can say option A is correct. So this completes the question. Thank you.